Hello, this is the first reteach video of the school year. Today we're going to reteach what we've learned about squares and square roots. First of all, during this thing, I'll call it a radical or a square root symbol. Missed a word right here. This little checkbox with a line across the top looks like a check mark with a line across the top. This is a radical. We call it radicals, or we can also call them a square root symbol. When we talk through this, remember perfect squares are squares of whole numbers. And we have a chart of those in our science or in our math notebook. The square root of 1 is 1, square root of 4 is 2, the square root of 3 is 3. These are all of our whole number integers all the way up to 13. So when I talk about squares and square roots, this is what I mean. Many of you have seen this before, where you have a number with a little 2 up there. That little 2 is a superscript, and it means that the number has been squared. That means that you're taking the number and multiplying by itself. So in this example, 4 squared really means 4 times 4, which equals 16. What we're talking about in class is the square root. The square root is the opposite of this little 2. So let's say we're going to work this problem backwards, and I have 16. I need to think in my head what number multiplied by itself will give me 16. And the answer is 4 times 4 equals 16. So that means the square root is just 4. We can understand this a little bit better if we look at a square. There is a reason why these numbers are called squares and square roots. Let's say I have a square, and I can tell you that the sides are 4 inches by 4 inches. Well, I can figure out how much space is inside of this square if I take 4 inches and multiply it by 4 inches. Altogether, I know in my brain that 4 times 4 is 16 inches. We also call them square inches because they have two dimensions. They have a length and a width. I could do this problem backwards using these same numbers. Say, here's my square. Sorry, they're not perfect. And I don't know much about it other than its area equals 16 inches squared. Normally, I could just count out, do I have 16 spaces? Yes, I do. So in my brain, I know a lot of you guys can look at 16 and say, oh, well, if it's the same number twice because it's a square with equal side lengths, then it must be 4. What you're really doing is taking the square root of 16. I'm going to move on. I'm going to do a few more examples of perfect squares, and then we'll move on to non-perfect squares. Let's say I have a square, and all I know is that the area is 81 inches squared. That's all I know. You go about finding it using the square root. So the square root of 81, I know that 81 has lots of factors, but one factor it's got definitely is that it's 9 times 9. If 9 times 9 will give me 81, then the square root of 81 equals 9. Because it's the square root of the area, that means it's also the side length of my square. We'll say these are inches. I did specify. If this side length is 9 and it is a square, this side length is also 9. Let's move on to non-perfect squares. Let's say I want to find the square root of 15. Looking at my perfect squares chart, I don't see the square root of 15 anywhere on here. But I do understand that 15 is somewhere between 16 and 9. So I know that the square root of 15 is somewhere between the square root of 9 and the square root of 16. Looking at this, I can also tell that it's closer to this one, which is the square root of 16. We're going to compare the solutions to this problem. So the solution to the square root of 9 is 3. The solution to the square root of 16 is 4. So now I know that my solution to this problem is somewhere between 3 and 4. Now, I can look and say, well, is it going to be closer to the value of 3 or closer to the value of 4? If it was right in the middle, that would be 3.5. But I can tell by looking at these numbers that 15 is much closer to 16 than it is to 9. So I know that my final value is going to be closer to 4 than it is to 3.5 or even to 3. So I'm just going to guess. It's probably somewhere around 3.8 or 3.9. You can check this with a calculator. On your calculator, you hit the second button, this little blue one. You go second, and then you click the square button, and it puts a square root up for you. I need to know the square root of 15. You can close the parentheses or not if it's the only thing you have in there. Once I do that, I hit equals, and I'm given a value. If I take this irrational, non-ending number and I were to multiply it by itself, I should get exactly 15. But since we don't want to deal with numbers this long in class, we're just going to round up to the nearest tenth. So 3.87 rounded to the nearest tenth would be 3.9. That was really close to my guess, 3.9. Now, if I wanted to double check, I could take 3.9 and multiply it by itself. And because I rounded, it will not be exactly perfect, but it should be pretty close. I have 15.21. Let's try another in between. How about the square root of 90? I'm going to reference my square root chart and I'm going to figure out where it would be. 90 is not quite 81 and not quite 100, but I can tell that 90 would be somewhere in between. So I know that the square root of 90 is somewhere between the square root of 81 and the square root of 100. The square root of 81 equals 9, and the square root of 100 equals 10. So I know already that the square root of 90 is somewhere between 9 and 10. That means it must be 9 point something. I'm going to go ahead and write that down. We're looking for a number that's somewhere 9 point something. Mathematically, I'm going to try to figure out, is it closer to 9 or is it closer to 10 or is it somewhere in the middle? The value 81 is only 9 away from 90, and the value of 90 is only 10 away from 100. So I'm comparing 9 to 10. That's pretty even. I'm going to guess it's pretty close to 9.5, which would be right in between those numbers. This is just my guess. I'm estimating. If I want to know for sure, I'll go to my calculator. I'll hit second and then the square sign, which will give me the square root symbol. Sorry, you can't see that. I'll type in my value, 90, and hit enter. And it gives me 9.486. If I wanted to round that to the nearest tenth, this 8 would bump up, so it'd make this 4 a 5. So my value is going to be really close to 9.5. If I wanted to check my work, I could go 9.5 times 9.5, and that would equal 9.25, which is very close to 90. Let's do one more together of these in-betweens. I'm going to choose a larger number this time. Let's say I want to know the square root of 150. I know that the square root of 150 is somewhere between the square root of 144 and the square root of 169. The square root of 144 is 12. The square root of 169 is 13. So I know my number has to be 12 point something. It's 6 units. 150 is 6 units away from 144 and 19 units away from 69. So I know it's going to be